So as I have told you, for small samples having sample size less than 30, so n is less than 30 in this case, we have two tests. One is this t-test, another one is this f-test. Now in t-test, what we do, we compare the means. And in f-test, what we do, we compare the standard deviations. So this is the basic difference. So today here we first of all will look at the t-test. So here what you may do, you may either check whether the mean of sample is different from the mean of population. So basically we will check this for the single mean, right? When you have only one sample. In the second case, you may also check the difference between means for two different samples, right? As we have done in the z-test. And then you may check the paired t-test. So now here in the second case, when you check it for difference between mean of two samples, you may have two things. One thing is that the two samples, they are independent of each other. And the second thing is that the samples are dependent on each other. So if the samples are dependent on each other, so there we would use the paired t-test, right? So this is the basic overview. So first of all, we are going to start with t-test for single mean, right? So when do we use this test? So you use this test if you have a random sample is present with you. Random sample means all the sample entries, they are taken randomly from the population having size n. This sample is available to you from the normal distribution. So that means the population follows the normal distribution in this case. So then we can use this test. So here what we can formulate that as your null hypothesis H naught, that first thing that you may formulate is that for H naught, it is the sample has been taken from some population having mean as mu naught. So that means what would be your hypothesis here? H naught would be that x is equal to whatever value is given to you. This mu naught would be some numerical value. So it would be equal to this number. This is first thing that you may check. And what would be the alternative hypothesis? So alternative hypothesis would say that, so it would say that this x bar, the sample mean, that is not equal to mu naught. So here we would say that there is a significant difference between the sample mean and population mean. And in the null hypothesis, we would say there is no significant significant difference, right? So this is what we do. So here in this particular case, what would be your t statistic? That is important. So what would be t statistic here? So that would be given by x bar minus mu naught divided by s divided by square root n, where again, so you may see that this statistic is equal to that of z statistic. However, here the number n would always be less than 30 because here the sample is a small sample, and here the distribution, the degree of freedom, if the sample has n elements, then the degree of freedom would be n minus 1 for sample, for n sample, for n as the sample size, right? So we will use this thing here, where what is s? First of all, what is x bar? That is the mean of the sample. And how do you calculate the mean of the sample? Summation xi divided by the total number of elements present in the sample. And how do you calculate this s? So you calculate this s by computing the square root of the difference of squares, the usual method by which you calculate the standard deviation. However, in earlier cases you were dividing that by n. In this case we will divide by n minus 1 because n minus 1 is the degree of freedom for this particular thing, right? So we shall see an example of this test later on. For now, this is the basic idea for this t-test, and we may use this whenever our sample size is less than 30.